In this video, we are going to solve 2006 AP Calculus AB FRQ question. So it says, at the intersection in Thomasville, Oregon, cars turn at a rate L of t equals that function over there, cars per hour over the time interval t is between 0 and 18. The graph of y equals L of t is shown above. Okay, so that's a graph of the derivative because that's the rate. Okay, to the nearest whole number, find the number of cars turning at the left intersection over the time 0 t, which is less than or equal to 18 hours. So, part A is pretty easy. If you want to find how many there are, you just have to integrate. So you would integrate between the boundaries 0 and 18, and you would write L of t dt over here, and you would use your TI-89 or whatever calculator you had, and you'd get about 1,658 cars. Okay, pretty easy so far. Part B. Traffic engineers will consider turn restrictions where L of t is greater than or equal to 150 cars per hour. Find all values of t for which L of t is greater than or equal to 150. And compute the average value of L over this time interval. Indicate the units of measurement. Okay, so now what you have to do is you got to set L of t to 150. So what that means is you're going to get your TI Inspire or TI-89 and you're going to type in 60 root t, you could use x, sine squared t divided by 3 and use the solve button equals 150. So there are 2 points where this is going to occur. It's approximately 12.428 and also approximately 16.121. So now, if you want to find the average, you got to do 1 over b minus a, the integral a to b, the function L of t dt, but in this case we're going to use 1 over 16.121 minus, what was a 12.428, and you would integrate from the 12.428 to the 16.121 L of t dt, and when you integrate this, you're gonna get approximately 199.426. Now we have to say what this interval is. Before it was cars per hour, so what would our units be? It would still be cars per hour because you're finding the average. If you just found how many cars, you would just integrate and it would be cars. Like this one was just cars. But since we had 1 over b minus a, it's time, so it's cars per hour. This is the hours part. Okay, part C. Traffic engineers will install a signal where any 2 hour time interval, which the product of the total number of cars left and total number of cars going straight through the intersection is greater than 200,000 in every 2 hour interval. 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? Explain the reasoning that leads to your conclusion. Okay, so we have 200,000 cars. We have to divide by the 500, and we get 400. So wherever it's greater than 400, that's where it's going to be over 200,000. So now we're going to look at our graph. This is our rate graph. So right here, we could see clearly that anything here is going to be bigger than 400. So 2 hour time period, that's 13, that's 15. So you would say the integral from 13 to 15, L of t dt, is greater than, well, you have to actually find what that is, and that's 431.931, which is greater than 400. So yes, you would need a traffic signal. Yes, you would need a traffic signal. Okay, I hope this video helped, and I'll see you next time.